Okay, thanks. So, write the major product for the following. Write these three questions. Assalamu alaikum, Hanifa. How are you?
Welcome, sir. I'm fine. How are you?
I'm also good. Eid Mubarak, by the way. Quite late Eid, but still. Is any one of you in India or both of you are in Middle East only?
I'm in India.
Hanifa, you're in India. Where do you enjoy the Eid more? Here or in Middle East? It's the same everywhere or what? Hanifa, Rifat?
Sir, what did you say? I didn't hear you.
Sorry, can you speak loudly?
I didn't hear you. You were lagging.
I could not understand. What did you say? You
Sir,
here?
I couldn't understand what you said before because your voice was cracking.
Okay, I was asking, where do you enjoy the Eid more? Here in India or in Middle East?
Mm, Uh, it's the same
It's
both places. So
the same both the places. Okay. What about you, Rifat?
Probably India.
Sorry?
Probably India.
Probably India. All right. It must be okay for you guys to celebrate in Middle East because you have been, most of you are born there and being brought up also. But I think for your parents, it's very difficult to understand the Eid culture there in Middle East. Like those who have been brought up completely in India and when they go for work and see the Eids there, it's very dull for them at least. You must be fine, born and brought up. Okay, Hanifa, were you present in the last lecture?
yes, sir.
Yes, no? The halogenation. I hope you
Yes.
guys remember how to make the major products, right?
Yes.
So the drill is the same. You will write the products and then send it to me on WhatsApp. Yes, Rishit, I have got yours. Hmm. Okay, there's just one thing. In the C product Rifat, can you please tell me my icon? Yes, Rifat. So in the C product, you have changed this to CH2. Why is that?
Oh, sir, that was a mistake.
Sorry?
That was a mistake.
Okay, just a mistake. Okay. Okay, just remember that you don't have to change the CH2 here. Okay. You just the carbons which are forming double bond. One of the carbon it loses a hydrogen and the other carbon loses a halogen. If sometimes students they make this mistake that they remove the hydrogen of other additional carbon atoms also sometimes. Okay. Others are fine, very good. Hanifa, are you stuck or something?
Sir, I'm doing.
Doing it? Okay, fine. हनीफा जल्दी भेज दीजिए. हनीफा प्लीज लेट मी नो इफ यू आर स्टक. ठीक है ना, इतना टाइम मत लगाइए. अगर नहीं हो रहा तो फिर बताइए, हम आपको हेल्प कर देंगे.
Sir, I'm not getting the last one.
लास्ट वन. ओके. हनीफा डिड यू सेंड? यस हनीफा.
Sir, I've sent it, but like it's not going. So,
Okay. I will see when you have I receive your answers. I will check it. Okay.
okay.
Now
Okay.
Right? And it's a very important question. Okay. So in exams, you can be asked. This is very important for your CBSE exams. In board, they can directly ask you reaction of alkyne halide with aqueous pH gives substitution and alcohol is formed. But when it reacts with alcoholic KOH, then it undergoes what? Elimination. And alkene is formed. Okay. So for this, you will like to answer. Since aqueous KOH, rather since alcoholic KOH, okay, since alcoholic KOH contains alkoxide ion, RO negative, okay, alkoxide ion, which is stronger base, stronger base, it can eliminate hydrogen. It can do what? It can eliminate hydrogen completely from the, this is beta, okay, from the beta carbon of alkyne halide. Of alkyne halide. But aqueous KOH, contains hydroxyl ions, which being a weaker base and good nucleophile. Is what? It is a weaker base and good nucleophile. It cannot eliminate hydrogen completely from beta carbon and gives substitution reaction. Okay. So I'm underlining a few things. See, as you can see, it is quite a big answer. So this question can be asked for 2 marks also and for 1 marks also. Okay. So when it is asked for 1 mark, then what you like? Alkoxide ion is stronger base and hence it can eliminate hydrogen. Okay. Can eliminate hydrogen from the beta carbon. Okay. So these are the words that you have to remember. In KOH, what do we have? In KOH, we have alkoxide ion, which is stronger base. And that is why what it is doing, it is eliminating the hydrogen. It is abstracting the hydrogen. It is attacking the hydrogen. But aqueous KOH, it contains hydroxyl ion, which is weaker base and good nucleophile. This is one thing that you have to remember. And that's why what it can do, it cannot eliminate. Okay, and that is why it gives substitution reaction. Is that clear? So there are a few things that you have to remember. Alcoholic KOH, alkoxide ion, stronger base. Aqueous KOH, hydroxyl ion, weaker base. Okay. So I'm writing a bit of conclusion here, just for you to remember. In alcoholic KOH, alcoholic KOH, alkoxide ion. Stronger base, that is why elimination. Okay. But if you have aqueous KOH, here we have hydroxyl ion, which is weaker base, and that is why it will give you what? Substitution. Okay. No, but why is this happening? This is something that you will write in the examination. But why is alkoxide ion, which is stronger base, it is giving elimination? We will talk in the terms of reaction also. We will look at what is happening in reaction. Why does it? Both of these are what? Both of these are electron-rich species. Alkoxide ion is Ro negative. Hydroxyl ion is OH negative, or you can write HO negative. So only there is a difference of R and H here. And why is that difference so influential that one is showing elimination reaction and the other one is showing substitution reaction? Hanifa, I have not received your answers till now. Can you send anything on WhatsApp, like just a text or something?
So I don't have Wi-Fi, so I'm using a data, so it's too slow. That's why.
But with the same data, you are attending the class also, no?
Yeah, it's slow. That's
Yeah,
why.
so it must go, I guess. Can you send something, anything in the WhatsApp? I don't know whether I have your number or not also.
Let me see.
Yes, I have your number. Okay, by the way, write these things, okay? Then both of you, yes or no, please tell me. Both of you have written the answers, Hanifa and Rifat.
Yes.
Yes.
Okay, fine. Now please write with me. No, don't write, okay? I will show you guys what is happening here. So let us suppose you have something like this. CS3. Okay, so this is our haloalkane. Please don't write, okay? Please don't write. This is our haloalkane. Now, if you see the first step, what is going to happen? Whether you have RO negative, so what will be RO negatives? Generally, it is alcoholic KOH. So when we write this alcohol is C2, sorry, C2H5OH, ethanol. Okay, C2H5OH. So when you have alcoholic KOH, the nucleophile, or sorry, the electron rich species that you are going to get is C2H5O negative. Okay, so this is what you are getting if you have alcoholic KOH. Please listen, don't write. When you have aqueous KOH, okay, when you have aqueous KOH, then what are you getting? You're just getting OH negative. So first of all, you will tell me which is smaller, aqueous KOH electron rich species is smaller, or the C2H5 is smaller? Which is smaller? Which is smaller?
Aqueous skin.
Right. So the electron rich species that we are getting from aqueous KOH, it is small. If it is small, then what does it mean? It means that it has a tendency, what it can do, it can attack this delta positive here. It can go to the carbon atom. But please remember, when it is going towards the carbon atom, what it has to do? It has to break through and it has to move through these hydrogen atoms which are present, right? These hydrogen atoms and this bond, carbon bond, right? So it has to go through these all atoms, and only if it is a small base, if it is a small base, it means base means electron rich species. If it is a small electron rich species, then only it can attack this carbon atom. But since C2H5O negative, it is a very large atom, then what it has to do? Okay, so it has to just attack on this hydrogen atom, which is on the outside, and take the hydrogen atom electron with itself. And what it will be doing, it will be forming C2H5OH. Okay, C2H5OH. So the only difference that you can see here is first thing is of size. So since OH negative is small, it can penetrate and it can attack on the carbon atom which is inside the hydrogens which you are seeing. But C2H5O negative, it cannot go inside and it cannot break through the boundaries of hydrogen. So it has to attack the hydrogen and it will abstract the hydrogen and it act as a base. The another thing is, we all know C2H5 will be CH3 followed by a CH2 and then followed by a O negative. Now this CH2, what it will be doing, it will be pumping electrons on the oxygen like this. It will be pumping electrons here, electron donating group. Now that is why the charge here will increase, right? So the charge is increasing here, and that is why it is very unstable. That is why it is more unstable than OH negative. Now it means that it also doesn't have the capacity to break in through these hydrogen boundaries, and furthermore, it does not have even time to break through this boundary because it wants to react as soon as possible. So it sees hydrogen as the first entity which is electron deficient, and it pumps its electron and it donates its electron to this H here, and it abstracts this H from here. Okay, so this is how it happens. This is how it happens. Why alcoholic KOH? It is giving you abstraction of beta hydrogen, but OH negative, it is attacking on the carbon which is attached to hydrogen. So when it's OH negative will attack, this Br negative will move on forward. So you got this, yes or no? Hanifa and Rifat?
Yes.
Yes, sir.
Yes, okay. Great. Now, since this is done, we will write the next topic. Please write this with me. Reaction of haloalkane with metal. Reaction of haloalkane with metal. Please write it with me. Number 1. Reaction with magnesium. In this you write when alkyne halide reacts with Mg metal. When alkyne halide reacts with Mg metal in the presence of dry ether. Okay, So once again, what do you think? Dry ether is solid or liquid? Hanifa and Rifat, what do you think? Dry ether is solid or liquid?
Solid.
Solid. Hanifa, what do you think? Solid or liquid? Hanifa, am I audible? Let's see here.
It's liquid.
It's a liquid. Yeah, correct. Dry ether is liquid. Okay. Now, dry ether is liquid, but why it is dry? Dry here means absence of water. Dry here means what? It just means absence of water. Okay. So it does not mean that it is gas or solid. Dry ether means ether which is present without the presence of any water or even any moisture. Okay. So empty metal in the presence of dry ether, it forms compound having formula RMGX. Having formula RMGX called Grignard reagent. Okay, called Grignard reagent. So it has a bond like this. For example, you have carbon with 3 of its bonds with something else, carbon or hydrogen, and 1 of its bond will be with Mg. Okay, and then it will be followed by X. So as you can see, here we have a carbon atom, and this is a metal, right? So this is a organic part, and this is a metal, right? So these type of substances are known as organometallic compound. Organometallic compound. Okay. Now, what is the importance of these organometallic compound in your 11th and 12th standard? The most important thing that you will remember here is, now what is a metal? It has a tendency to lose electron. Is that right? Yes or no? Hanifa, Rifat? Metal has a
Yes.
tendency to lose electron. So this Mg will be pumping electrons towards carbon. Okay. And Mg will be delta positive, and here the carbon will be delta negative. Can you see how it is very different from whatever we have seen till now? We had always Rx. Here X was delta negative and carbon was always delta positive. But in this case, carbon is more electronegative than the metal, obviously, and that is why it is having a delta negative charge. Okay, so it will be very useful if we want to attack some electrophile here. That means if we want to attack carbon with some positive charge, then we will have this type of Grignard reagent, and this E positive will be attacked by this carbon's electron rich source. Okay, so please remember this, the charges also. Write this down. So what it will be known as, for example, if we have CH3 MgBr, okay, so it will be named as methyl magnesium bromide. Okay, and for example, if you have something like this, C2H5 MgCl, it will be ethyl magnesium chloride. Write this down, then write the reactions, and then our important note. Done? Yes, Hanifa and Rifat.
Done.
Done, sir.
So it makes the reaction that we are talking about here is the reaction of haloalkane Rx with magnesium. It is going to give me RMgX. It will give me RMgX. If you have, let us say, CH3, CH2Br plus Mg, what is going to happen? We are going to get CH3, CH2, Mg, Br. Okay, and this can also happen if you have haloarenes also. Okay, so this is also possible for haloarenes. Here you have, let us say Br, Mg, it's going to give you MgBr like this. Okay, so see, this is already, we have named this. This is ethyl magnesium bromide. This is phenyl. Okay, this part is known as what? Phenyl. Phenyl magnesium bromide. This will be cyclopentine. Magnesium chloride. So write these reactions. And then you will see why the Grignard reagent is made. It is prepared in the absence of moisture or water. Okay, in the absence of moisture in anhydrous condition.
Sir, what will be the first one known as?
Sorry,
The first one.
this one.
Yeah. No, the CH3, CH2.
First one, CH3, CH2. This is ethyl magnesium bromide. I know. Yes, got it.
Yes.
No. So you, I was just, we have named this actually. No? यहाँ पे देखिए. C2H5 था. It's here. It is C2H5. It is just magnesium chloride. Here we have magnesium bromide. So first name this part. Ethyl magnesium bromide. Now, Hanifa, I got your answers now. First one is correct. I'm waiting. Third one आपने नहीं किया है. Third one नहीं आया मेरे पास अभी तक.
Sir, I didn't get the third.
Oh, बताना चाहिए ना. वही तो हम पूछ रहे थे आपसे. Are you getting stuck on? Okay, wait a second. I will tell you. Done, guys. Yes or no?
Yes, sir.
Done. Okay. Yeah. So Hanifa, can you please turn the mic on?
Yes, sir.
1, 2, 3, 4, and 5. So from which of the carbons will the bromine go away? Tell me. From which of the carbons? 1, 2, 3, or 4? The halogen atom. So we will break a bond between CX, right? So which CX bond will be
Yeah.
broken? From which carbon? 4?
3, 4, and yes.
Fourth, no? Fourth carbon. So this bond will be broken. Okay, that means you have to look the carbon atoms which are adjacent to this fourth carbon. So what are the carbon atoms? 3 and 5, yes or no?
3 and 5, yeah.
Yeah. So you can either make a double bond like this, or for a major product, or the double bond will be like this, correct? Yes or no? That
Yes,
means
sir.
the double bond can be made by either here or here. So tell me which is major. What do you think? First one or second one?
The first one?
Yeah, correct. That's it. Okay. So what are the question I asked? Tell me. Okay, see, starting से लेके end तक आपने बस answer किया, right, Hanifa?
Yes.
Right. So I just asked you questions. If you remember these questions, then you will be doing any question, right? Yes or no? कोई भी problem होगा, कोई भी reaction होगा. If you ask yourself these type of questions, then you will answer it on. First of all, you will identify the CX bond that has to be broken. क्या करना है आपको, Hanifa? What you have to do? The first thing,
Identify the CH bonds that has to be broken.
CX bond. Which bond?
CX bond.
CX bond. And then what you will see? You will see the adjacent carbon atoms to this carbon atom, right? So this carbon atom is the bond which has been broken. Then you will see what are the adjacent, and then you will make two products, and then you will see which is having more alkyl group along the double bond. Clear? Yes or no?
Yes, sir.
Okay. All right. No. Write this in terms of question only. Okay. So whatever question I'm writing in between now, these are very important for your CBSE examinations. Write the question. Grignard reagent is always prepared in anhydrous condition. Why? Your answer here. Since Grignard reagent is very reactive in nature. Reactive in nature. Due to which it reacts even with moisture and forms alkane. Okay. So see, if you have R mgx, then this R will be delta negative, right? Plus you have water. Water is HOH. As you can see, this H will be what? Delta positive, right? And see, magnesium is a metal, so it has a tendency to give electrons. It will just lose electron, it will form mgx negative. Okay, so I mean, even if you see a bond here, it is not even a bond. It is completely negative charge here and completely positive charge here in the Mg. Okay, so it is like that. Now what will happen? They are just in the vicinity, I would say, nothing else. They are just in the vicinity. There is no covalently bond atom because magnesium is pure metal, right? So what will happen? This R negative will attack on this H positive and will form R H plus what we'll be getting? We'll be getting MgX OH. Okay, so this is alkene. Okay, so that is why if this reaction happens due to the reactive nature of Grignard reagent. It will react with water, and then what it will form? It will form alkane. Okay. As soon if you give a small amount of water, also it is going to form alkane. That's why it is done completely in anhydrous conditions. Done everyone? Yes, please tell me.
Yes, sir.
Right, next. Reaction with sodium. So again, see, this is a name reaction. So in your notebook now, you have to keep these things like this. For example, as soon as you have written this, what's the reaction? So we write this name reaction. Okay, so what these things will do now, these things will help you in making short notes, and while you are revising things, you will pay more attention here. So right, a reaction with metal. Okay, and this is known as what? This is Ward's reaction. Write this. When two same haloalkane reacts with sodium in the presence of dry ether, to form alkane. Which has double the number of carbon atom is called Wood's reaction. Rx plus Rx, two same haloalkane. In the presence of sodium, right? It will form alkene, which has double the number of carbon atoms. So what is going to happen? R and R, they will form a bond, and you will have 2NAX. Okay. Then you can please tell me. Done?
Done.
Okay. Write a note. Rather write a remark type of thing. This reaction is not applicable for two different haloalkane. because it gives mixture of alkenes which is different, which is not which is difficult to separate from mixtures. Okay. For example, if you have Rx haloalkene and you take another haloalkene that is R dash X. Okay, R dash X. In the presence of sodium and dry ether, it will form what? See, only this haloalkane also can react and it can form RR because ये तो एक ही नहीं होगा ना. I hope you guys remember. If you have okay, please stop writing and listen. Okay. So if I have just 1 mole, that means there are 6.022 to 10 to the power 23 atoms or 3 molecules of Rx. So many of this Rx can also react and they can form RR. Right? What else they can form? Both of these can react and they can form R and R dash. Only this R dash X can react and it can form R dash and R dash. Okay. So this is the mixture that you are getting. And that is why we don't do this reaction with 2 different haloalkane. We do this only with 1 haloalkane. Is that clear? Hanifa and Rafat?
Yes.
Yes, sir.
Done? Yes, and tell me.
Done.
Okay. Okay. We'll write another remark. Before that, you write a mechanism here, okay? Then you will understand. Okay. So in mechanism, what happens? First of all, you have sodium atom. Okay, and it will give you have 2 sodium atoms, it will give you 2 sodium ions. Each sodium atom will give you 1 electron and you will be getting 2 electrons like this. Okay, you will be getting 2 electrons like this. Now, further what happens? We have 1 haloalkane that is Rx. It reacts with 2 electrons and these 2 electrons, as you know, this is delta positive and this is delta negative. What will happen? These electrons, it will react with R positive here and it will form what? R negative plus X negative. And as you can see here also we have 2 charges and the product also we have 2 charges. Okay, so don't worry, you are getting both of the things negative. Here what is happening? This 2 electron it is attacking on this R and this bond is getting cleaved. So now we have R negative plus Rx. Now what is going to happen? This is delta negative, this is delta positive. Now this R positive will be attacked with R negative and you will be getting RR plus X negative. And you can see here we have 2 Na positive, here we have X negative, another X negative. In total, what is happening? We are getting, when we have two Na plus 2 Rx, RR plus 2 NaX. Okay. So you see what is happening? One of the R is getting R negative. Okay, and that is very crucial. That will also explain the next remark. Okay, please write this down. लिख लिया आप लोगों ने, ये सुनो, हनीफा एंड रिफत?
Yes, sir.
Okay, now write the third point. लिख लिया कीजिए तो फिर एक बार बता दिया कीजिए, ठीक है? जस्ट कीप रिपीटिंग. Okay. Now right, Wood's reaction is not shown by tertiary haloalkane because it undergoes elimination. And gives alkene as the major product. Okay, so let me show you how this happens and why this happens. Okay, please see here. If I have a 3-degree alkene, tertiary haloalkene, then I will be having CH3, CX, and there will be a CH3 here. There will be a CH3 here. So I hope I can write this reaction directly, the second step, okay, in which it is reacting with 2 electrons. So once it is reacting with 2 electrons, it will be forming CH3, 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 and there will be a negative charge here, okay, negative charge here. And the next reaction, what it should do, it should react with another haloalkane of the same thing. If you see the mechanism, you will understand, right? And what it has to do here, it has to attack and penetrate through these all CH3 molecules, and it has to attack here in this carbon. Is that right? Yes or no? Please look at the mechanism here. Same thing is happening. Look at the step. The last step here, R negative is attacking on carbon, which is bonded to halogen atom. Yes or no? Hanifa and Rafat, can you see that?
Yes.
Same thing we have done here. C negative, it is attacking. But what do you think? Is this attack feasible? Is this attack possible? It is very bulky. Yes or no? And we have seen that when you have a very large electron-rich species, then it tends to not attack on the carbon atom. Rather, what it will do, it will attack on which atom? Tell me. It will not attack on carbon. Where will it attack then? What happens in elimination? Where does it attack? On the yeah, Rifa, tell me. Where does it attack? भूल गए.
Hydrogen atom.
Hydrogen atom, right? It will attack on one of these CH3's hydrogen atom, okay, because it cannot penetrate through all of these CH3s. Rifat and Hanifa, both of you understand this? Yes or no? Please tell me.
Yes.
What about
Yes,
Hanifa? Yes?
Yeah.
Okay. Fine. So what will happen? Once it attacks this hydrogen atom, it will be forming CH3, CH, CH3 and CH3 plus. What will happen to this molecule? Hydrogen will be abstracted and this X will leave and it will be forming CH3 doubly bonded with CH2 and CH3. Okay, so please write this down. It's not shown by tertiary haloalkane. Write this.
Done, sir.
Both of you done? Both of you done, yes or no?
Done.
Done. Okay. So, the question, write the major products for the following. Okay. So I hope you can make the first product. See, all of these are having two molecules. Okay. And maybe two molecules of sodium also. Sorry. So here what will happen? CS3 and CS3 will join. Here what will happen? You'll break the bond here. CS3, CH2, and then CH2, CH3. I hope you are getting hold of that. Yes or no, please tell me. Plus NABR.
Yes, sir.
Plus 2 NABR. Now please listen here what is going to happen. In this case, this carbon atom will be bonded to the same carbon atom. Okay, so the bonding will be from this carbon atom. Okay, it will not be a straight chain. It will be having some branches like this. CS3, CH, CH2, CS3. And if the Br is here, just write the same molecule in the side. And you write it like this: CS3, CH, CH2, CS3, and then they will bond them like this. Same goes for here. Right for the fourth one. Okay, as I have done for the third one, the fourth one is very similar. Do this. Send me answers, okay? Rifat and Hanifa for the last one.
So can you explain the third one again?
देखिए हमने उसका मैकेनिज्म ही आपको दिखा देते हैं. Okay, so please see. CH3, CH, CH2, CH3. So this Br will be there. It will react with 2 electrons that is given by sodium. है ना? तो ये कहाँ अटैक करेंगी? It will be delta positive here, so it will be attacking here, right? And this Br will leave from here, and you will be getting CH3, CH negative, CH2, CH3. Correct? Yes or no? Please tell me.
Yes.
Right?
Sir.
Okay. Furthermore, you have same molecule like this now. We have CH3, CH, CH2, CH3. It will attack on the other haloalkane. And how it will attack? This will be having delta positive. So this negative charge will attack here, right? And this Br will leave. And what we will be forming? CH3, CH, CH2, CH3. And the bond will be with CH here, which is having a CH3 molecule here. CH2 and CH3. Yes, Rifat and Anifa, समझ में आया?
Yes. Sir.
Yes, okay, fine. Sure. All right, for this last one, fourth one here. I will show you the mechanism. Wait a second. So the ऊपर कर देते हैं बस. हाँ. I hope everything is in your view now. Yeah. Yes, Arifat, very good. हनीफा भेज दीजिए, कभी ना कभी तो आ जाएगा. हनीफा, okay.
Yes, sir.
हनीफा, हाँ, okay. चलिए. Similar to this reaction, there is another reaction which is known as fatigue reaction. So please write. This is also a named reaction. Okay. Fatigue reaction, right? When two same haloarenes. So here what do we have? Here we have haloarene. When two same haloarene reacts with sodium in the presence of dry ether, to form biphenyl. It's called fatigue reaction. So here we have haloarenes. We'll have same haloarene like this. What will happen? Here you will get 2Na. Very same as you had the Wurtz reaction. It is the same reaction but for haloarenes. Sorry, write this down. This is biphenyl. Okay, here we will have dry ether, okay? Done. Yes or no?
Done.
Done. Okay, right. Next. Now the next reaction is also very similar. It is a mixture of both of these. Okay, so it is known as Wurtz fatigue. It is also again a name reaction. And right, Wurtz fatigue. Reaction. So what happens in this? When one molecule of, please write with me, of haloalkane and one molecule of haloarene reacts with sodium in the presence of dry ether, it forms alkyl benzene. Okay, it forms alkyl benzene, and the reaction is called Wurtz-Fittig reaction. Okay, so in this what happens? You will have a haloalkane and haloarene. Presence of dry ether. So again, what will happen? This X will move from here, this X will move from here, and you will get alkyl benzene. So बस यहाँ से आप X हटाइए benzene से, and you will put up there R. Okay. You write this down. So for example, I will have, let us say, CH3X, CH3Br. I have here, let us say, Br, the sodium, presence of dry ether, it will give me toluene or methyl benzene. Okay, so this is toluene. Write this down. In the next lecture, we will look at the chemical reactions of haloarenes and some important aspects of SN1 and SN2, which is that we will look at the stereochemistry and all. And then this chapter will be done, inshallah. Okay. Okay. Also, tomorrow you will have a test. Topic will be chemical properties. Okay, so we'll start with SN of haloalkane. Okay, nucleophilic substitution of haloalkane till today's lecture. It will be of 10 marks, 30 minutes. And tomorrow you will have lecture. It will be of 1.5 hours. Then you will have 30 minutes test. Clear? And if I'm referred, yes or no, please tell me.
Yes, sir.
Yes.
Okay. So all the chemical properties are done till now. Then we will have a test. Okay. Just 1 second. 1 second. 1 second. एक चीज़ हम आप लोगों को लिखाना भूल गए. I will write that. You don't need to remember that. Okay. You know how to make the product in dehydrohalogenation. उस वो rule हम लिखाना भूल गए as a text. Okay. I will do that in next class. Right. I just have to just anti-Markovnikov, you know how to make the product, right? Similarly, you know how to make the product in dehydrohalogenation, major and minor. I just have to write this down once. Please remind me tomorrow, okay? But I have to teach you guys. No, let me write it here only. Tomorrow I will start with Sedzev rule. Then I will remember this. Fine. Thank you guys. Thank you very much. We'll meet tomorrow. Assalamu alaikum. You have written this? Yes.